Hello, everybody. This is Exennial Thought, and today's topic I wanted to talk about technology and what are some of the technologies that I think are really interesting right now, and what are some of the technologies that I think will be game changers in the next 5, 10 years. So, a little bit of background. I've always been very interested in new and cutting edge technologies, even some technology that is so far out there that it's probably just nonsense or a conspiracy, or we may not see for another 20 years, 30 years on any production scale, um, aka fusion power, something like that, or quantum teleportation on a larger scale. But anyway, a little bit of background. So, um, my first degree was a Bachelor of Arts in Literature Philosophy, and this was back in 2005. But while I was studying to get this degree. Basically, I always found myself going to grocery stores and libraries and bookstores, and I would just pick up books and magazines on science and technology. So even though I was reading a lot of other type of books, classic literature and things like that in school, um, I was just on the outside of class. I would just be picking up, Popular Science or Discover magazine or Scientific American, just reading about all these new technologies all the time. And I even picked up a few books on that stuff, and I just read it on the side instead of reading my books in class. So it's always been an interest of mine. Anyway, so I graduated and I ended up going back to school for engineering. I basically studied renewable energy engineering. It's a Bachelor of Science. It's actually the first ABET accredited degree program of that nature in the nation where I went. It's at Oregon Tech. So it's still a program you can do if you're interested in that kind of stuff. Just fair warning. So the renewable energy engineering degree is kind of a misnomer. It's actually more of a traditional power engineering degree, and it's about 70% traditional electrical engineering combined with about 30% traditional mechanical engineering. So it is intensive. It was a difficult course, and there was a handful of people who would start the program each quarter at the beginning, and they drop out after that because it was too difficult, or they didn't think they thought it was going to be something different than it was. It's very hands-on, it's very technical, it's very math heavy, and it was a real engineering degree, and it's a Bachelor of Science. And so I finished that in 2011, and then I went to work in the industry for about 6 years, working on basically doing the power systems and doing power engineering and implementation for large vehicles. So that was all fun. I may go back into that field at some point, but right now I'm taking a little hiatus, and this is one of my outlets on the side. So anyway, all that being said, I've always been really interested in cutting edge technology, and I still am. It's what kind of keeps me going, I think. It keeps me curious and keeps me interested in this crazy world. I love learning about new things and how they're going to change our lives, and also about things in the past that have changed our lives. So, without further ado, what do I think are three of the biggest game changers that are being investigated, or being researched, or being developed right now, or will be more within the next 5 or 10 years? First off, I got to go for the low hanging fruit. I would say blockchain and cryptocurrency. So, if you're not familiar with this stuff by now, then I think you haven't been paying attention. So, cryptocurrency and blockchain have really been around on some level for quite some time, at least some of the ideas and some of the theories behind them, but it wasn't really first successfully implemented on a large scale and on a worldwide trust scale until the advent of Bitcoin, which I think was first released in, was it 2008 or 2009 was the first block. And so Bitcoin basically combines a couple different technologies into one thing, and the combination of those things make it really revolutionary. So it combines encryption and cryptography, which creates a lot of the security with network file sharing, which is kind of the backbone of something like Napster or BitTorrent or something like that. And so digital money has been attempted at many times in the past, and there's been different groups and different businesses that have attempted to create the ability to send money through the internet over distances, and I think PayPal was the first company that really got that part right, and connected it up to the banks and made it reasonably secure. But there's big issues with doing it on a large scale and doing it like in a decentralized network manner. And the problems with those are the two biggest problems are called the double spending problem and the copy problem or copyright problem, whatever you want to call it. And the first thing is the double spending issue. And the double spending issue is basically there's a latency between digital messages being sent from one location to another. And so if you have money in a digital wallet online and you send it to a business or a vendor to buy something, and before that money, that digital money gets sent to them, you simultaneously send the same message to another location to buy something. So you send $5 to one place. Before they receive the $5, you send the exact same $5 to another place. And the net effect is that you can buy two things for the price of one before your account gets credited with losing that money. And so that's one thing that Bitcoin solves. The other issue is the copy problem. So whenever you have digital assets or digital content online, it's really easy to copy it. So, for example, music files, images, text. So you can copy and paste any of that stuff, and it's just zeros and ones. So how do you stop someone from just copying and pasting digital money from one place to another place, and then all of a sudden you have twice the amount, right? Well, the combination of technologies that go into cryptocurrency and blockchain in general pretty much solve that problem. And I'm not going to get too technical, but just in general, it uses an algorithm called SHA-256. And basically you have a network of computers that are inputting in a random hexadecimal number. So it's basically an alphanumeric number into this algorithm. And the output is more or less a random, it's not random, but it looks random, output string, which is another hexadecimal. And the hexadecimal has to have a certain number of zeros in it in order for you to win the block. So what is a block? Well, a block is basically a bundled up pool of transactions that people are trying to put on the network. So if you're trying to send money from one location to another, pay for something somewhere, that is a transaction. It goes into a pending pool, and then computers that compete to create the next block or the next bundle of transactions will take all the pending transaction and build it up into this block, which is part of this larger ledger. And then at the same time, they're crunching all these numbers through the SHA-256 algorithm to try and get a certain number of zeros in a string. And then once they get to a certain number of zeros in a string, then they win that block, and then they propagate that winning string of numbers across the network, and all the other computers verify that they in fact got there first with the right amount of zeros at the beginning of the hexadecimal. Therefore, that is tried and true, and therefore we need to recognize that they won the block, so they get the new Bitcoin, they get the reward, and then all those transactions that were pending now become true. And then that's connected to the block before it, and then every block after that is connected to that one that was just created. I know it's kind of fuzzy or kind of confusing. I didn't explain it very well probably, but there's plenty of videos online and plenty of information to read about it to make it a little more clear. But nonetheless, what I'm getting at and what I said earlier is that it was a game changer with how digital money is used, created, and propagated through the network. So it basically combines the security that wasn't there before, and it prevents double spending, and it prevents copyright. So it's really a game changer. Now, there's a lot of different cryptocurrencies out there now. There's a lot of different blockchains that are trying to do slightly different things. And there's some people that will argue that, well, Bitcoin is the only true one, and it's the only one that matters because it was the first one, which I think is just a silly position. I think it's actually... it's really a tribalist position, and I think it's just emotionally charged, and people who really take a so-called maximalist position on any cryptocurrency. You see it, I think, more so with like Bitcoin, but anyone who takes that position, I think, is missing the bigger picture. And if you disagree or you're a Bitcoin maximalist, feel free to talk shit in the comments, but doesn't necessarily mean I agree with you at all. I just think that it's not going to be a zero-sum game. I think if you try and compare cryptocurrency or the emerging blockchain tech to other industries or other software technology companies, I just think that's kind of a fool's. I think it's sort of like a fool's gesture, and the reason I believe that is because it's just a very different technology. So, if you go back to say search engines, right? So there's a lot of different search engines that were competing to be the main search engines. There was Yahoo, there was um, what the hell were there? I think AOL had one. There's Google, of course, and I can't even remember all of them. There were so many back in the day, but nonetheless, Google got the algorithm right, and they were the one that ended up becoming the dominant search engine. Then you had social networks, and so there was a bunch of different social networks, and there's Friendster, there was MySpace, and then Facebook. Got the user display right, and they got the balance between um, the real account versus made up account and the nice clean interface. They got it right, and so it just became really popular, and that now it's a dominant one. You go back even further, and you go back to some of the software companies, and there's a lot of different software companies, and now there's just kind of a handful of them. There's Microsoft, there's Apple. And I don't know what you'd call Amazon. That's kind of its own thing. That's kind of taken on its own life, but nonetheless, there's a lot of reasons why I think the cryptocurrency sphere will be very different, and part of it is because, um, for one, nation states all have their own fiat currency, and yes, they might peg it to the U.S. dollar more or less, but there's just a lot more diversity when it comes to money, when it comes to assets, and when it comes to ways to transfer and hold value in things. Therefore, I don't think any one blockchain will be perfectly designed or perfectly programmed to take on all of these different transactions of values and allocations of values. So, for example, Bitcoin, I think, is looking like, okay. I think it's the most secure or one of the most secure blockchains. I'm pretty sure it's the most secure, but it also is slow, and it's very difficult to upgrade it, and it has an older, unique programming languages that I think is specific to Bitcoin, and it's difficult to tinker with, by design, and it's kind of rudimentary, but it also makes it more difficult to hack. It makes it more difficult it has a smaller attack surface because it's kind of simple and basic, rudimentary. So Bitcoin might find a good niche in the future where you have nation states that need to pay each other large amounts of money, so on the orders of hundreds of millions or billions of dollars. And instead of going through the normal banking network or however long it takes, which it could be days or weeks before those payments get settled, they might just use Bitcoin and just send that securely across the interwebs, and it could settle. You can have a settlement of payment or a finality of payment within 10, 20 minutes, right? So it might make sense for that. And also the other use case would be like digital gold. If people just want to hedge against the volatility of currency or volatility of just normal market fluctuations, they might put in a certain amount of money in Bitcoin with the expectation that it holds its value through times of turmoil. So that's good. And then you have other more complicated use cases where you might want to use something like Ethereum, which can do smart contracts. So if you have a multi-party team where each person has to do a different type of input um, before an output happens, and it gets a little more complicated, you might want to use something like a smart contract, right? Another application for smart contracts would be like games. And so if you have these online games where people are exploring a land and they're finding items or buying items or trading items, you can associate a real world value to that, which is designated in some kind of Ethereum based token, an ERC20 token, or whatever type of token you want to use. And then those could be tradable and purchasable in game. And then they could be transferred out, or they can be even traded on like an open exchange for real money. And so something like Ethereum would be really good at facilitating something like that. Then when you look at high-speed payments, so you might have situations where you want to pay small amounts of money at really high volumes with many, many users and many, many people, like Visa level type transactions.